Okay, so lesson 23, matrix equations. Solving system equations using what we call inverse matrices. Cramer's rule helped us go through, and we can do it through determinants. Works pretty well. Had a limitation when that determinant was 0. Couldn't do it that way. Here we have another way to do it. It's the matrix equations. So what we do is we take our system of equations, whatever they happen might be. In this case, I have a real simple two-variable system, an XY system. And what we do is we first take that and turn it into a system of equations into what we call a matrix equation. Every matrix equation will have the coefficients as a matrix, just like they did in Cramer's rule, that first matrix. And then we'll have a matrix that is just our variables, and then we'll have a matrix that is just our constants. So what does that look like? Well, that would look something like this. We have our A1 and our A2 and our B1 and our B2. Those are our coefficients. We have our XY matrix, and we have our C1 and C2. Now, if I'm going to solve that equation, I know all I have to do is divide by that matrix out in front. Now, what I did is I add a little note over here. That coefficient matrix, we can call it A. So if we're using the calculator, the coefficient matrix is our A matrix. The constant matrix is our B matrix. The variable matrix never goes into the calculator. So we know if I'm going to solve it, I just got to get rid of those numbers in that matrix A, so I could divide off of matrix A. But we can't divide off matrices. So what we do is we first find the inverse matrix. We have to find the inverse of matrix A. Now, much like Cramer's rule, if the determinant of this coefficient matrix is 0, we can't find the inverse because we know that the inverse is 1 over the determinant times whatever. Got it? Yeah. So again, if we get a determinant 0, we got a problem. We don't have a unique solution. We got to find a different way to do it. Okay, so then what we do is to find the solution, all we do is multiply both sides of the equation by the inverse of matrix A. Now, if I take the left-hand matrix here and I multiply this side here by the inverse of matrix A, my A's cancel off. Because I put it first, I'm going to put it first on the other side too, and I'll put my matrix A there. Here we're going to cancel off, the other side we're going to get it. So what we find out is that our variable equals our inverse of our matrix A times the matrix B. Those two matrices are going to look exactly the same. That's our solution. That would be our X and Y. So this method can be used if we have two variables like I have written up here, or if we have three variables, or if we have four variables. We don't have to make a whole new matrix for each one of those like we did in Cramer's rule. We just make this equation and we solve the equation. So let's go ahead and try this out. Get those notes off of there. I have 3x plus 5y equals negative 14, 2x plus 6y equals negative 12. We could solve this any one of the ways, but we're going to go ahead and use the system that we're talking about right here. So our first step is we need to find the matrix of the coefficients. And then we have our variable system equals our constant system. So now, step 2 is we need to find the inverse of this matrix. So the first thing we have to do is find its determinant. Well, the determinant would be 18 minus 10, which is 8. So its inverse, if I call that A, so the inverse of A, or if you prefer, A to the negative 1, would be 1 over 8 times the matrix 6, 3, negative 2, negative 5. Well, if this is my matrix B, all I got to do to find the solution is take my inverse of A, which I had down here, and multiply it to my inverse of B. So I'm going to take 6 times the negative 14, negative 5 times the 20, get that answer by adding those together. 6 times 14 is a negative 84, plus 100 gives me a 16. So I have a 16 over an 8. Let me put the B right there just so we know what's going on. I get 16 over 8. And now if I do the same thing, I'm going to take negative 2 times negative 14, that gives me a 28. 3 times negative 20, so negative 60. 28 minus 60 is a 32. Negative, so I get a negative 32 over 8. And now if I reduce those, I get a 2 and a negative 4 in my matrix. Well, that means the x has to be a 2 and the y has to be a negative 4. Well, the answer key I got said just that. A is x is a negative or a positive 2 and y is a negative 4. So there, I just did that whole thing without a calculator. Just so you know. Whole process without a calculator. And you can too. That doesn't really work real well when I make that the B and I moved it over. Okay, so this is my B matrix. Got to get that back in there. B matrix. And that's what I got. Okay. So now, what if I have a three-dimensional system like we have over here on the left or on the right? We still have to be able to create the matrix equation. So I have a 3, a 0, and a negative 3, a 5, and a negative 3, a 3, a negative 4, and a 1. That's my coefficient matrix. And then I got my x, my y, and my z. And then my constants are 15, 13, and 12. Now, I could go through that whole process of doing this by hand, but this is one of those cases where doing this by hand would be a nightmare. Give me a second, I gotta go grab my calculator. Okay, got my calculator. I put the matrix A into my calculator as A, I put the matrix B into my calculator as B. First thing I check is, what is my determinant of A? And I got an 84. So that means this has a unique solution. I can go ahead and work it through. So then all on the calculator, I just told it, give me the inverse of matrix A, multiply that by matrix B, and I've got, so A inverse times B, and the calculator tells me 2.75, negative 1.5, negative 2.25. So guess what? That's my x, my y, and my z. Now my answer key had a slightly different answer. It said my answer was 11/4, negative 3/2, and a negative 9/4. Check it. 11 divided by 4 is 2.75. 3 over 2 is 1.5, but it's just a negative offer. 9 over 4 is 2.25. I got the same answer as what the answer key says. So guess what? We have another way to solve system of equations, and this is called the matrix equation method. We use inverse matrices to solve it. All you got to be able to do is find an inverse of a matrix and be able to multiply matrices, and you can do this method. It's all yours now.